this. Another example. This time is a numerical example. We have two capacitors which are serially connected to each other. And this is a circuit. We have a switch over here. And we have a battery right at this point. Close the circuit. So this is C1 and this is C2. And the C1 is 6 microfarad capacitance and C2 has 12 microfarad capacitance. And this battery is 12 volts. Okay. And this is just a switch. And let's label these points. This point label as A, and this point will label as B. Okay. So the question is, when the switch is open, both capacitors are empty. You know, they just neutral. They don't have any charge on the plates. And next thing is, when you close the switch, what happens? And you just close the switch. What happens to the capacitors? What happens to the voltage difference between the terminals of capacitor 1, C1, let's call this V1. After you connect this, you just close the switch. What will happen is that, you know, charges will flow from the battery to the capacitors, which are in series, and the capacitor will get charges. And whenever the capacitor gets charges, it will develop a potential difference between its terminals. And obviously, for both capacitors, C1 and C2, they will have a potential difference across their terminals. So when S is closed, originally S was open, when S is closed, what are the values of V1 and V2? Okay, so this is the question. So when you close the switch, you know, I said the battery will, since providing a potential difference between these plates of the capacitor system, right? The charges of each plate of the capacitor will get charges. Let's say that C1 plates of the C1 will get charge of Q1, and plates of the C2 will get charges Q2. Okay. And once the charges, the capacitors get full charges, there will be no more charge flow from the battery to the capacitors, and there will be no any current flowing through the capacitors. The capacitor will get the maximum charges, Q1 and Q2, whatever these charges are. And in this position, of course, capacitor C1 will have some potential difference across its terminals, and C2 will have a potential difference across its terminal V2. And one by one, what are these potential differences? So we know that, you know, Q1, C1, and V1 are related to each other by this equation. Q1 is C1 times V1, and Q2 is just C2 times V2. So can we find V1 and V2 from these equations? You know what the C's are, you know C1 and C2, but the thing is, to find V1, You don't know what Q is, right? What Q1 is. V1 is Q1 divided by C1. You know what the C1 is, but you don't know what Q1 is. Okay. Well, how can you find these charges? After all, my question is Q1 and Q2 are different?
Eşitler hocam. Q1 ile Q2.
Q1 ile Q2 birbirine eşit.
Evet.
Neden?
Eğer bunların eşdeğer kapasitanslarını aldığımızda yükleri birbirine eşit çıkacak. Çünkü aynı voltaj alıyorlar. 12 volt. 48 yük çıkacak yükleri. Eşit olarak paylaşacaklar. Biri birincideki voltaj olarak 8 volt alacak. Diğeri de 4 volt alacak.
One thing we know that these V1 and V2 are not the absolute potentials. After all, they are the potential differences, right? One thing we know that the potential difference between the first plate of capacitor C1 and the second plate of capacitor C2 is 12 volts. And what I mean is that V1 plus V2 is 12, okay? This is something we know, right? You know, but the thing is, the question asks, not the sum of these two, but individually, what are these? And your friend said that, you know, Q1 and Q2 is going to be the same. How? Okay. Q1 and Q2 is going to be the same. And I ask why. So what we do is we just replace these two capacitance, right, by an equivalent capacitance, which is connected to 12 volts. And this is equivalent capacitance. And we know what the equivalent capacitance is. It is just because of the serial connection, C1 multiplied by C2, C1 plus C2. I mean, this is 6 times 12 divided by 6 plus 12. And 6, this is 18, right? And we can make a simplification. This is 3, right? And 12 divided by 3 is 4. So it's 4 microfarad. Okay. So the equivalent capacitor is 4 microfarad. And this capacitor will get the charge in one of its plates, Q. Something we can find, right? And this charge, the equivalent capacitance, will get the charge in its place as C equivalent times V, but we know what V is because it's connected to 12 volts battery, and this is 4 microfarad multiplied by 12, and it is going to be 48, right? 48 microcoulomb. Okay. But the thing is, it seems that, you know, we found the charge of an equivalent capacitor, not the individual charges of Q1 and Q2. And these plates are connected not parallelly but serially to each other. We claim that Q1 and Q2 is going to be the same. And this is true for all serial connections. If you have many different capacitors, C1, C2, C3, etc., Cn, which are serially connected to each other, obviously you will say that this one will have Q1 charge, Q2 charge, Q3 charge, Qn charge. And I say that if these all capacitors are serially connected to each other, all the charges will be equal to each other. In electrostatic equilibrium, okay, since there is no change in the current, if there is no change in the current, if there is no current flowing between these capacitors, then all charges must be equal to each other, right? if there is any difference between the charges of these plates, there will be some current flow. But since we don't observe this, there is no current flow. Once the capacitors are fully charged, all the plates must have the same charge. Otherwise, there will be some current that flowing from a larger charge to a lower charge. So since this we don't observe, that we can say that Q1 is going to be equal to Q2, and in fact, it is nothing but 48 microcoulomb. Is that okay for all? So now, since we know what Q1, Q2, and all values of this, we just put to find V1, we just put instead of Q1, 48 microcoulomb, and this is going to be divided by C1, where C1 is just 6 microfarad, okay? And this makes V1 to be 8 volts, okay? And similarly, V2 is going to be Q2 divided by C2, and Q2 is again the same 48 microcoulomb, and C2 is different, it is 12 microfarad, and we get 4 volts. So V1 is 8 volts, and V2 is 4 volts. When you add these two, you get really 12 volts, which is the voltage provided by the battery. Okay, so this is how you find the voltages of serially connected capacitors. But these voltages are not absolute voltages. They are just the potential difference, the voltage difference between the plates of each capacitor. So, any questions for this? And next is that if you assign a potential, and this is the second question, and I must erase this part to ask the second questions for the same problem. So I'm just erasing this part. Anyway, you will get this when I record. I just share the recording with you. Let me erase this part. Knowing that now V1 is 8 volts, right? Was that correct? And V2 to be 4 volts. And Q1 and Q2 are just 48 microcoulombs. Was it like this or other way around? V2, 4. Yes, it's correct. Okay. So now the question is, if VB is at 0 potential, okay, if you know the potential of VB 0, what are the potentials of each conductor in the circuit? Okay, so this is our next question. So what are the conductors in this circuit? Let me erase these. Okay. So the conductors in this circuit are, I'm seeing 1, 2, 3 conductors. I'm seeing 3 conductors in this circuit. The first conductor is this one. You see, all the parts on this is a metal, and all the points on this metal is at the same potential, because this is the definition of a conductor. If a conductor is in electrostatic equilibrium, all points on the conductor or on the metal, whatever, metal is a conductor, all points on the metal must be at the same potential. This is something we know from earlier chapters, right? And since all the points we see are connected to each other, if VB is at zero potential, then every point on this conductor must be at zero potential, okay? And what is the second conductor? What is the second conductor in this circuit? The second conductor is this one. This longer bar of the battery and this wire and until the upper plate of the capacitance C1. This is the second conductor because this is one piece of metal, you see? This is one piece of metal. And since it's a metal and it's a conductor, every point on this conductor is at the same potential. It is at the same potential with the potential of point A, VA. The question says that since it is given VB is at zero, what is then VA? So what do you say? Any idea? If this point is at zero potential, what is the potential of VA? Let me erase this because we know the second conductor is this one. So what is the potential of point A? And what is the potential of this conductor? If the potential of VB is zero. Any idea? What is this?
12 volt.
So VA is 12 volts. Bu aksesuar değil burada. Şu. Well, it's very easy, you know. Just think about this. Grab a voltmeter, find a voltmeter, okay, and connect the voltmeter probes to the terminals of battery. That's it. And any battery, if you measure its voltage, will give its voltage value. It's already given in the problem. Well, this point is equivalent to this point, right? Because VB, they are the same conductor. So if you know the potential of this, the potential of this point must be 12. And the potential of VA. Okay? So it's very easy. Okay. So you know how to solve this kind of questions. No. Next, what is the third conductor over here? This piece is the first conductor. This piece is the second conductor. And this piece is the third conductor. There are three conductors in this circuit. Okay? And the question is, what is the potential of this conductor? Let's assign a point C over here that we ask the question VC. What is VC? Any idea?
4 değil mi hocam?
4 mü?
Evet.
4. Nasıl buldun?
Yani V1 yani birinci kapasitör 8 volt kullanacak. Bundan dolayı geriye kalan 4 volt kalıyor.
Evet. Şimdi burası 12 volttaysa burası 12 volttaysa, şununla şunun arasındaki fark 8 voltsa, değil mi? 12 volttan kaça düşmem lazım? 4'e düşmem lazım. Doğru mu? Anlaşıldı mı? So if VB is at zero potential, VA is at 12 volts, right? And VC is 4 volts. Why? Because we already calculated what the potential difference across the terminals of C1. It is already calculated as 8 volts. And if this is on 12 volts, and if difference is 8 volts, you have to drop from 12 by 8, which makes the potential of C, VC, to be 4, right? And just check. You are crossing from point C to point B. The potential change must be just V2, 4 volts, right? But you're already at VC, 4 volts, but this is at 0 volt, so the difference is just 4 volts. This is the verification, okay? All right, so what you have learned on this example is that, first of all, if two capacitors are serially connected to each other, the plates of every capacitor, however, whatever the number of capacitors which are serially connected, must have the same charge. All the plates must have the same charge. And this is one thing you learn. And the next thing is, how to calculate how to find the conductors in a circuit. This is the way how to find the conductors in a circuit. And this circuit has 3 conductors. And possibly if I add a resistor like this, and think about yourself that what is going to be number of conductors in a circuit in this case. Okay, think this on your own. Think about it. Okay, so that's the end for this question. And I will stop here. For this week. Okay, and we will continue with the next chapter, which is the current and resistance, next week. Okay, so we'll meet again next week and the same time at 11 o'clock on Thursday, and we will do also problem solving afternoon after the morning lecture. Evet arkadaşlar,